Okay, so once again, geometric sequences are exponential functions. And the first thing you need to know is that the formula for that is G sub n equals the first one in the sequence times some ratio to the n minus 1. So on all of these sequences, you're going to see that instead of adding or subtracting the same number to each one, you're multiplying or dividing. Okay? So the recursive formula in this one is G sub 1 would be the first thing you'd write, and then G sub n equals the ratio times the last number in the sequence. Okay. R is a ratio. So it's by some number that you're going to multiply. Okay, so if you invest $10,000 in a year in a 5-year CD with an annual yield of 4.83%, the amount you begin with and the amounts you have at the end of consecutive years form a finite geometric sequence. This is something that you guys have seen in the past. This is the formula for this. A equals P is the principal of 1 plus R the rate in decimal form to the T value. You guys remember that? I think this is last year. Okay? So if I'm going to make a explicit formula for this, it would be the following. A equals, what's my principal amount? 10,000 times 1 plus, what's my rate in 0.0483, yep, to the T power. Okay? I'm going to write this again, just a little bit simplified. Not in this case. Yes? 1 plus R. Yeah. Yeah, it didn't tell us to solve it. It just told us to make the formula. So if we were to solve it, we would put 5 in for T. Yep. Would it be wrong? No, because you would have had to come up with the explicit formula to solve it. Okay, find the recursive formula on this. Okay, the recursive formula would be the following. It's going to be our G sub 1, which is what? 10,000. And then my A sub T in this case, at any time, is going to be 1.0483. That's my ratio, my little r. Because that's what I'm multiplying each one by. But because we're adding to it, you got to add that 1 to it. Otherwise, it would make it smaller, right? So this is my little r. And then I'm going to put in A sub T minus 1 because it's dependent on the last one that you had in the sequence. Recursive, remember, always depends on the last one that you had. Okay? All right. 1B talks about a car that depreciates 20% its first year and then 10% each year after. If the original value of the car is $20,000, find its cost after 2 years. So first of all, we want to find out what its cost is after 1 year. Okay, so let's do that first. Yep. So I'm going to take 20% of 20,000 and subtract that from 20,000, right? So 20% in decimal form is what? 0.20. Okay? And if you do that, you'll find that at the end of the first year, the car is only worth $16,000.
Wait, why are you thinking by 2005?
I'm taking the original amount and subtracting the amount it depreciates. Okay?
For 2 years, you take 16,000 multiplied by 21.
Yes. So it'll be 16,000 minus 0.1 times 16,000. So if you put that in your calculator, you'll end up with 14,400. Okay, so here's where it gets a little interesting. Notice that the first year it has a 20% depreciation, and then thereafter it has 10%. We can't rely on A sub 1.
Well, can we just say that A sub 1 is 16,000?
We want to say A sub 1 is this one because it's going to depend on this one from here on. Okay? So I'm going to write this like this. C sub n.
Wait a minute. But why would it not depend on the 16,000?
Because it's going to go down by 10%
We haven't taken the.
from this point on.
But after 60, once you get to the 16,000
Because
mark,
it's
then
only
it's 10%
20%.
from there on.
But it's not 10% every year, or it's not 10% of the
If it was 10% of the first year, then we would be considered.
Basically, the first then year. You'd start with 20,000, wouldn't you?
No,
Yeah,
it
Tori.
doesn't go back up.
Tori, you've already, basically, because you timed it by the 10,000, you've already did 1 year. So then you start from the rest of
You
that.
start from 16,000.
You really do start from 16,000.
Because after the first year, you already took 20% off. After the
That's a good question. Let's try this, guys. Let's see if this turns out to be the same thing, okay? 16,000 times 1 minus 0.210 and have it n minus 1 instead of n minus 2. No, because it's the year before this one, right? Okay, so let's just check and see if that changes anything, okay? It may not. So let's try n of 3 for each one of these and see if it makes the same value.
And she took out another.
Yeah, so, ladies and gentlemen, so we just found out that these two are equal to each other. Okay? So either you can start at year 2 and make that your base and work from that, or you can start at year 1 and make this your base and work from that. But if you're starting at year 2, make sure you have n minus 2 at the top. If you're starting from year 1, have n minus 1 at the top.
Wait, how do you know what your n is?
That's the number of years.
They tell you that.
Yep.
But you put not, what is the not?
Okay, so our recursive formula here is going to be the following. I'm going to put, if you're going to start with year 1, okay, our first one's going to be 16,000, correct? Okay, and then it's going to be C sub n equals C sub n minus 1 times what?
0.1 to the n.
Not 0.1, but it's 1 minus 0.1, so
Well,
0.9, yep. Okay, to the n. Or no, just that, because it's a recursive. It's just one issue. That's it. Okay? All right, so let's go on to the next page.
Wait, don't get that yet.
Okay, this one says, consider the arithmetic sequence of 70, 77, 84, 91, and 98. Pick any 3 consecutive terms. I'm going to let you guys do that right now. I want you to go through A and B right now on this and try it yourself and see what happens. Pick 3 of them in a row. Consecutive means in a row. I picked these 3 right here. So I added 77 plus 91, and I got 168. And then I divided that by 2, and I got 84, which happens to be what? That middle number, okay? Now it says, consider the geometric sequence. Do the same thing. Follow the directions on this and see what you get. Yep, so I'm going to pick these 3 right here. It doesn't matter which 3 you pick as long as there's 3 in a row. So if I did this, it's going to be 80 times 1280. and I get 102, 400. And if I take the square root of that, I ended up with 320, which happens to also be that middle term again. Interesting, huh? Okay. Now, we need to find the explicit formula for all of these problems here. The first thing I would recommend you do on these is I would check to see if it's arithmetic, because that's really easy to find once you find it, okay? So check to see what your differences are. So what's the difference between 18 and 24? Okay, 6. What's the difference between 24? So that's your common difference already, right? Here, I'll put another one up there, just so that we don't have that. Okay, so this will be equals D. That's your D. Okay? So what would be my next two terms on this if I add 6 to it? 42. And what's the next one? 48. Okay? So now I need to put into my formula a sub n equals a sub 1 plus n minus 1 times d to find my explicit formula. What's my a sub 1 in this case? 18. And we're going to distribute that 6. So I have 18 plus 6n minus 6.
So 12.
Yep, 12 plus 6n. All right? Nope, just wants explicit.
Whether arithmetic or geographic.
If you're adding the same amount each time, that's arithmetic. Okay, so let's put that on the side here.
You would also do check.
Yep.
Also check if they might do that there.
Okay, so arithmetic, you're adding or subtracting. Okay? Geometric, you're doing what? Multiply or divide. Okay? And like Juliana said, we can just check it too by doing the tricks that we just did above. Okay? So you can check it by, on this one, you could add 1 plus 6 and divide it by 2, and do you get 3? Yes. Let's try it again. 3 plus 10 divided by 2, is that 6? No. Okay, so that's not right. The other way I like to check each one like this. My differences here are 2, 3, and 4.
How do you know if they're neither?
Yeah, this. Okay, so this one, if I find my differences again, 1 and 1 is on the second time. What kind of a function it gives me on the second common differences? Quadratic. So it's not going to be either one. This one's quadratic.
So would this be, you'd have to put in your calculator?
Yeah, this one we won't even do right now. Yeah, you would have to put your calculator and do a quadratic regression. Okay? This one, let's find our differences again. What's the difference between this one and this one here?
4,
It's going down by 4. It's negative 4. How about here?
negative 3,
Negative 3.
negative 2.25.
Negative 2.25. So it's not arithmetic, right?
It's neither.
So let's try this. Let's take 12 divided by 16. What do you get? Or 0.75, 3/4. How about 9 divided by 12? So what is this type of series? Geometric, correct. Okay, so what's my next term if that's the case? Yep, multiplying by 3/4. Okay, 5.0625, I'm just rounding it up. And what is that times 0.75 again? Okay, and I rounded that up to 3.8. All right, so my explicit formula on this is going to be a sub n equals my first one, which is what? 16. What's my ratio? 0.75 to the n minus 1. So that's your explicit formula on this one. How about this one? What is my differences here? Yep, it's geometric. It doesn't work out arithmetically. So if I did this 48 divided by 96, that's 1/2, right? Or 0.5. And 24 divided by 48, once again, that's 1/2. So you know it's geometric. So what is my explicit formula here?
Would be a sub n equals 96, and in parentheses 0.5, and raised to n.
Correct.
Are we done?
Almost. Okay, let's look at E. This one's neither. This one's a special case. Do you guys know what kind of a sequence this is?
Oh, is it the golden?
Yes.
Ratio?
Fibonacci. Fibonacci. Basically, this is taking,
N minus 1 plus N minus 2.
yep, n minus 1
Doesn't it go like
plus n minus 2.
1, 1, 2, 3, 5?
Yeah.
You skipped
Yeah, they skipped the first two. So 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Do you guys see it now?
8 plus 13 is 21.
Yep. Okay, I'm going to finish this tomorrow.